Okay, now let's look at this question. Two particles of mass 0.25 kilogram and 0.35 kilogram are placed 0.155 meter apart. A third particle of mass 0.055 kilogram is placed in between them. See that? In between them. In between them. So this third particle is between the first and second particle. Between them. Calculate the gravitational force acting on the third particle if it is placed 0.055 meter from the 0.35 kilogram particle. Okay, so first of all, let us find out what information given. We have here, actually we have a total of 3 masses. We put this one as M1, this one as M2. Distance between them, this is R12. Okay, and then the third particle we consider this one as M3. This one is M3. Okay, this one is M3. Yeah, in between them. So now I want to find the gravitational force. I want to find gravitational force, which is Fg. Yeah, but this gravitational force, I want it on the third particle. So we put this as F on 3. Okay, gravitational force on the third particle. It is placed 0.055 meter from the 0.35 kilogram. So this one is the mass 2. If we refer back to the one we denote it, it is mass 2. So this one is 0.355. So this is the distance between the third particle and the second particle. So we put this as R23. Okay, R23. So this one is the distance between third and second. Third and second. Okay, this is the mass of third particle. So this is the distance between the third particle and the second particle. So this is R23. So first of all, we need to draw a diagram to illustrate this situation. Okay, better we draw a diagram. See, I've drawn for you here. Okay, so this is mass 1, mass 2, 0.155 meter apart. Okay, and then mass 3 is in between them, but mass 3 is nearer to mass 2 because R23 is just 0.055 meter compared to the total distance of 0.155 meter. So this is just like 1/3 of it. Yeah, 1/3 of this. Okay, so we can say that mass 3 is nearer to mass 2. So I've also labeled down the value over here for easier reference when you want to do calculation. Okay, so the question asks for what is the force on third particle. This is important. On which particle? On third particle only. So what you have to do is you need to find the force only on third particle. Only on third particle. You don't have to draw the force on other particle. Force on first particle and force on second particle, not important. Not important at all. We know that, of course, these two between any two masses, there must be attractive force. The force must exist in pair. You see that? Force, gravitational force, cannot exist alone. You cannot say, oh, Mars has attractive force to Earth, but Earth has no attractive force to the Mars. No, these two forces must exist in a pair. When there is an action, there must be a reaction. There cannot be just only action without reaction. Okay, must exist in pair. Forces must exist in pair. If the Earth pulls the mouse also pulls the Earth. Okay, so gravitational force must exist in pair. It cannot exist alone. It must have two forces exist in one pair. Yeah, in a pair. So Earth pull the mouse. Earth pull the mouse. The mouse also pull the Earth. So these two forces must have a pair. Okay, must have two forces. Cannot have just a single force. So back to this one. Okay, so we know that between any two masses, they must attract each other. Like between mass 1 and mass 2, they must attract to each other. We can say this one is F. We consider this one as F. This one is F31. Okay, F31. That means this one is force of 3 on 1. Force of 3 on 1. And this one is F1 on 3. That means force 1 on 3. And then between mass 2 and mass 3 also have a pair. Okay, have a pair. So we can say they also exist a pair. So between 2 and 3, 2 attract 3, 3 also attract 2. So on 3, we can say this is F2 on 3. Yeah, 2 on 3. You see, on 3, it has the 3 behind. You see that? And then, okay, and then on 2, 3 also attract 2. So this one is F3 on 2. You understand? This is F3 on 2. So must exist in pair. Yeah, cannot exist just alone. And then between 1 and 2 also attract themselves. Okay, maybe I should use what color? Maybe I use purple color. Okay, between 1 and 2, 1 attract 2, 2 also attract 1. So we can write on number 1, this is F2 on 1, and 1 also attract 2. So here also we have another force. Okay, hold on a second, let me draw it out. Yeah, put it a little bit higher. Okay, so so this one also is attracted by 1. The number 2 also attracted by 1, which is F. We put it as F12. You see that 1 attract 2, 2 attract 1. So that's why we have a pair also, F21 and F12. Okay, between 1 and 3 also attract each other. So we have F31 and F13. And then between 3 and 2 also attract each other. So we have F23 and F32. See that this is 3 on 1, and this is 2 on 1. That means 1 is always behind. You see that 1 is always behind, and this one is mass 3. So this one is F1 on 3. So this is F2 on 3. So you can see the 3 is always behind. You see that? Always behind. And then for this one, mass 2, this is F3 on 2. And this one is F1 on 2. 1 on 2. So you can see the mass 2 here. So 2 is always behind. Okay? So that's all for I draw all the forces already. However, okay, I just want to put it over here. Okay, for reference later on. Okay, maybe I can group it first. Okay, so refer sometimes later. Now, the thing is, you look at these questions. You look back to these questions. The question says, calculate the force on where? Only on third particle. Only on third particle. So that means you only need to draw the force F13 and F23. Only these two forces we need to draw. All the other forces on other particle. This F31 and F21 is the force on first particle. And this F32 and F12 is the force on second particle. So, but the question asks for force on third particle. It doesn't ask for force on first particle. It doesn't ask for force on second particle. So all these other forces you need to rub off. You need to erase off. We don't want all the other forces. Understand? Okay. We don't want all the other forces. We only want the force on third particle only. On third particle. So you just draw F13 and F23 enough. All the other forces on other particle don't draw. Yeah, don't draw. You just draw the forces on third particle only. Okay, which is F13 and F23. Okay, so we need to find out what is this force F13. First of all, we need to find out what is the force F13. Okay, this is question A. F13. Okay, and we need to find F23 also. Okay, so how to find this value? Use the formula. F equal to GMM over R square. Okay, or M1 M2 over R square. So we can put it as this G is M1 M3 because it's between 1 and 3. So put mass 1 and mass 3 over R13 square. Okay, and then for the other is the F23 is between mass 2 and mass 3. So we use mass 2 and mass 3. Understand? Mass 2 and mass 3. So, and then divide by the distance between 2 and 3. Okay. So now, following is, we need to calculate, put in the value. Okay, we know that G value is 6.67 exponent negative 11. Let's put it inside there. Okay, let's find out what is F13. Okay, so let's find out. First of all, G is 6.67 exponent negative 11. Okay, you can find this value in the list of constant provided in the exam. So you don't have to memorize this value. Okay, this value will be given in the list of constant. Okay, during the exam. So it's 6.67 exponent negative 11. Am I correct? 6.67 negative 11. That's correct. Okay, put this further down the other side. Okay, this one go a little bit here. Second. So now, how about mass 1? Okay, what is mass 1? Mass 1 is 0.25 kilogram. Okay, so label as 0.25. And then mass 3, okay, and then mass 3 is, what is mass 3? What is mass 3? Is it given, mass 3? Third particle of mass 0.055 kilogram. Oh, the mass is 0.055 kilogram. Okay, it's the same value as the R23. Okay, never mind. So, okay, I just want to label first over here. Mass 3 is 0.055 kilogram. So, mass 3 is 0.055 kilogram. I label here so that easy for me to retrieve the value when I want to substitute the value. Okay, I always write the value in the diagram for easier for me to refer. Okay, I don't need to refer to the question anymore. Okay, so now continue. So mass 3 is 0.055 kilogram. Okay, put the value there, 0.055 kilogram. Okay, and then what is R13? What is R13? R13 is the distance between 1 and 3. Do we have the distance R13? No, we only have R23 and R12. We have this R23, this is R12. So we don't have R13, but very simple. We just take R12 minus R23, then we can get the R13. That is the use of drawing diagram. Easy for you to describe. Okay, so we need to find this value. Yeah, this one should be the distance between 1 and 3 is R13. So how to find R13? So let's put a calculation here. R13 is actually just take the R12 minus the R12 minus the R23, which is the R12 is actually 0.155. And then the R23 is 0.055. So what is the value? 155 minus 0.055. So it becomes 0.1 meter. Isn't it? Yeah, very simple. So this R13 is actually 0.1 meter. 0.1 meter. So we can label it. We got the R13 already. So we just put it below here, 0.1 square. Don't forget the square. Many students forget about the square. Yeah, forget about the square. That is called what? That is called careless. That's called careless. Yeah. So let's find out the value of R13. Okay, so I got the answer already. Yeah, which is 9.1713. 1713. I like to maintain more decimal place for accuracy. Okay, 4 decimal place I maintain. So exponent what? Exponent negative 11. I got that value. Okay, Newton. And then this one, the direction. You need to write direction also. Okay, this one is to the left. To the left. Or we can say towards the mesh 1. Okay, so that's the F13. Now how about F23? F23. So we need to calculate also F23. After we got the value for F23, then we need to find the resultant force from F13 and F23. Get the resultant force on mesh 3, on the third particle. We need to find the resultant force on third particle. Okay, so now find the F23 first. Okay, G, again, the value of G is 6.67, exponent negative 11. Okay, and then mass 2. What is mass 2? Mass 2 is 0.35 kilogram. 0.35. Okay, 0.35. And how about mass 3? Mass 3 is 0.055. 0.055. Okay, and then divided by the distance between 2 and 3, which is 0.055. 0.055. R23 is 0.055. Okay, square. Don't forget the square. Many students forget about the square after they substitute the distance. Yeah, what I can say is you are careless, yeah, when you forget the square. So now let's calculate the value for this also. Yeah, so what's the answer for this? F23. I got the answer is 2.2445. 2445. Exponent negative 10. Exponent negative 10. Newton. What is the direction of this force? It is towards mesh 2, or to the right. Okay, to the right. So we got the we got the forces already, F13 and F23. Now find the resultant force. Find the resultant force. We need to find the resultant force on third particle. The resultant force on third particle. Which we need to combine F13 and F23. So what is the resultant force? So the resultant force on the mesh 3, okay, resultant force on mesh 3 is equal to, okay, we take the forces to the right as positive, okay, force to the right as positive, force to the left as negative. Okay, force to the right as positive, force to the left as negative. So we can say F23 is positive, F13 is negative. So okay, F23 is positive. This is just direction. Positive means to the right, negative means to the left. So positive, negative just means about direction. Understand? So okay, let's do it. Let's do it. F23 is we can put this one. F23 is positive, and then F13 is negative. Negative. F13. Negative F13. Okay, so F23 is 4.2. Okay, 4.2445 exponent negative 10. Okay, 2445 exponent negative 10, and then minus what? Minus the F13, minus the F13, which is 9.1713 exponent negative 11. Do you see one thing here? That is the good of putting positive negative sign as direction. Because we know that when forces in opposite direction, they always cancel each other. They always minus each other. So by assigning positive negative sign to the direction of the force, we actually automatically minus the force in opposite direction. That's why you see this F23 and F13, they end up become cancel each other. They end up minus. So assigning positive negative sign for the direction to the right and to the left, very important. It helps us to arrange our equation so that when forces in opposite direction, they minus. When forces in the same direction, they add up to each other. Okay? That's it. So this one, it become minus. Okay, so what is the answer we get? Let's calculate, yeah? So I get the answer already, yeah? The answer is a positive value. What does it mean by positive value? Tell me. I got positive 3.327. This one I correct to only 2 decimal place. Okay? Final answer you maintain 2 decimal place. The process in between you can maintain at 4 decimal place, but final answer always maintain at 2 decimal place. Okay? Because the answer given always only have 2 decimal place. So this is 3.33, yeah, 327. So this is 3.33 exponent negative 10 Newton. So remember, for in the process in between, you put 4 decimal place. 4 decimal place. But the final answer always maintain 2 decimal place only. Okay? Last time I put 4 decimal place for accuracy. But final answer should always put 2 decimal place. Understand? One thing I miss out, I need to put direction also, because force is a vector. Force is a vector. A vector, you must have direction. So what is the direction of this force? So just looking at the sign, I get a positive sign. Positive sign, that means direction is to the right. Positive sign means to the right, or if to the right, if this force, the total force is to the right, that means the resultant force on mass 3 is to the right, which is towards mass 2. So you can write as towards mass 2 also can. Yeah, either way, you write to the right or towards mass 2, both accepted. Okay, so that is the answer. Okay, is that correct? Yes, that's correct. The answer of resultant force on third particle is 3.33. 3.33 exponent negative 10 Newton. That's correct. Okay. I actually missed out the direction also. The direction you should write to the right or towards mass 2. Okay. Okay, so now look at question B. Okay, look at question B. Just now is correct already. Okay, only 2 decimal place, final answer. Okay, look at question B. Determine where the third particle, so also refer to third particle, but now he asks for where. Where means need the position already. Okay, should be placed for a 0 gravitational force on it. So this time I want 0 gravitational force. That means now the total force on mass 3 should be 0. The resultant force need to be 0. Just now our resultant force on 3 is 3.33 exponent negative 10. Now I want the resultant force become 0. So where should the third particle be placed? This one. Okay. So all right. So we don't have. Let's say we don't have the distance. Okay, R13 and R23 we don't know. Okay, let's redraw the diagram over here. Yeah. So now we don't know what's the position. Yeah, we don't know where is the third particle. So this one, okay, I saw okay, my target is on third particle. Yeah, so my third particle. So only draw the force on third particle. So now we don't know where is it should be placed. Yeah, in order to have zero resultant force, zero gravitational force. So that means we don't have the distance yet. So the R23 we don't have yet. We don't have that yet. Okay, we don't have that yet. So we don't know. We don't know what is it. Yeah, what is it when the resultant force equal to 0? So we can just write this off. We don't know what is the distance. Okay, however, we can put this as x. Okay, we can put this as x. And how about the other partner? How about the other side? Okay, so let me ungroup this first. Okay, I just want to put it over here. Oh, sorry. Okay, let me see. Yeah. Okay, so we don't know this one. Yeah, we don't know this one. Okay, put it as black. So we have x here. We don't know what is this position yet. We need to find out what is x. Okay, so this is x. How about this part? This part you should put as r minus x. Yeah, r minus x. And this one we regard as r. Understand? This one we regard as r. R. The distance between 1 and 2 is r 0.155, and this distance here between 2 and 3 you put as x, and between 1 and 3 is the r, the long one minus the short one, so the remaining is r minus x. So we must build this first. So now we want to use, he say, the resultant force has 0. The resultant force is 0. The resultant force on 3 is 0. So apply this. Resultant force on 3 is 0. Okay. So resultant force on particle 3 is 0. Okay. So now this one, how we going to do is also we need to assign positive negative sign. Going to the right as positive, going to the left as negative. Okay. So now let's continue. So F23 is positive value, okay, because it's to the right, but F13 is negative because to the left. We put that as negative F13 equal to 0. And then what is the next step? Substitute the formula Gmm over r square for force. Okay, so this is F23, so we put as G mass 2 mass 3 over, okay, over what? Between 2 and 3. Between 2 and 3, the distance between them is x. We denote as x. We don't know what's the value yet, but we put as x squared. Okay, I mean the r here, the r here we put as x. Distance x is the distance between 2 and 3, so it's correct. Yeah, r squared, so we have a square there. Okay, next F13. How about F13? Okay, F13 is G mass 1 mass 3. Okay, between 1 and 3, mass 1 mass 3. Okay, between 1 and 3, mass 1 mass 3. And then this one, what should we put below here? Below here you should put distance between 1 and 3 is r minus x. R minus x square, okay, equal to 0. Okay, so how to continue from here? Okay, So this one actually can go to the other side. Yeah, this one and this negative become positive. So watch closely how I do it. So this become G mass 2 mass 3 over x squared, and then this one is G what? G mass 1, sorry, G mass 1 mass 3 over R minus X squared. So negative go to the other side, become positive. So this, you see, look for the common. The G can be cancelled. Divide by G, gone. Mass 3 also common, can be cancelled. So I got, so left with only M2 and M1 here. And then what should I do is for the square I put into one side, for non-square I put to the other side. So what I mean is this one go to the top, yeah, I minus x squared go to the top, okay, and then the mass 2 go below. Just exchange place. So here become r minus x squared, below is x squared, and then where is the mass 2? Mass 2 go to below here, so become mass 1 over mass 2. Okay, so but we don't want the square here, isn't it? We don't want the square here, so what we do is we square root both sides. When we square root, this one you need to add a positive negative sign. Add a positive negative sign. So again, what is mass 1 and mass 2? Let's put in the value also. So it is positive negative square root. What is mass 1? Mass 1 just now. That's why I like to write the information here. Easy to refer. 0.25. So mass 1 is 0.25. So put as 0.25 kilogram. And then mass 2 is 0.35. 0.35. Okay. 0.35. So next is we calculate. Yeah, let's calculate. Okay, this one after when we square root, we have a positive negative sign, isn't it? Mathematics. Okay, now at the left hand side, when we square root, it just left us with the square just gone. It just left us with r minus x over x. Okay, and then equal to, so what is the value over here? Let's calculate. Okay. So after I square root, I got positive negative 0.8452. Okay, and then the magic happens. So this one is you know, r minus x equal to the positive negative sign. So what should we do now? Yeah, so let's say it is okay, so this one has two cases. Yeah, multiply to the top, so we have 0.8452x or okay, or if this is a positive, okay, or we can put r minus x become a negative 0.8452x. Okay, let's continue. What is r again? R is 0.155. 0.155, so let's substitute that one. This one is 0.155. Okay, 0.155. And then minus x equal to 0.8452x. So what is the value x here? Let's calculate. Yeah, let's calculate. Okay, let's calculate. I got the answer already. Yeah, it is x is equal to 0.084 meter. Okay, this x is from where? This x is from where? Mass between mass 3 and mass 2. So this is actually R23. Okay, R23. Yeah, R23 between 2 and 3. This is R23. So I got this value. How about the other one? Yeah, let's put in the R over here also, 0.155, and then this one go to the other side will become, okay, go to the other side will become what? Will become, so that means this negative 1 go to the other side become positive 1. So it become 1 minus 0.8452. So which I get 0.1548 x. Okay, 1548x. So now finally I get x equal to, what's the answer? 0.155 divided by the answer, we get 1. Actually this is like considered like 155 also. Okay, okay, so like consider 155 also. So when divide become 1, this is 1 meter. Yeah, so this is another distance for f. This also f, this also the distance between 2 and 3. X is the distance between 2 and 3. So it's 1 meter. It's either, this x is either 1 meter. Oh, can it be 1 meter? Is it possible? No, it's not possible. X cannot be 1 meter. Yeah, x cannot be 1 meter because if 1 meter, if x is 1 meter, means it's more than 0.155, because the maximum x is until 0.155 only, cannot be more than that. Okay, so I got the x equal to 1 meter, which is you can say ignored, because it's outside the range already, outside the range. So the real answer is this one. Okay, or we can say we can say mesh 3 is located, mesh 3 is 0.084 meter from mesh 2. Right at this, mesh 3 is 0.084 meter from mesh 2, So that's the answer. Okay, this one ignore, 1 meter ignore, because it's more than the separation already, more than the separation between 2 and 1. Okay, more than that, so ignore that one. So the answer is 0.084. So is it correct? Yes, it is 0.084 meter, 0.084 meter from 0.35. 0.35 is mesh 2. So we got this actually, we got this one actually, this and this one is mesh 2. So it is 0.084 from mesh 2. 0.084 from mesh 2. That's correct. Okay, 0.084 from mesh 2, from mesh 2. That's correct. Okay. So that's it for these questions. Hope you understand. So resultant force 0. That means we put like this lah. Resultant force 0. Then we solve it. Yeah. Put the one distance as x. The other one is r minus x. Then you should do it. Okay. That's all. Thank you.